Hello everyone. In this class, I'll be explaining how to find out the centroids of simple elemental areas with reference to the given reference axes. Okay. So actually, that is required in finding out the distances of centroid with reference to with respect to the reference axis is necessary in case of finding the centroid of complex areas like this. Okay. um, we know that the formula for finding out the centroid of complex area is nothing but x bar is equal to a1 plus a1 x1 plus a2 x2 plus a3 x3 so on, okay, divided by total area A. Similarly, you can you will have y bar is equal to a1 y1 plus a2 y2 plus a3 y3 plus so on, okay, divided by total area A. So this is the formula. These are the formulas for finding out x bar and y bar for a given complex area. Okay, and here one should need to find out areas of simple. I mean, the areas of the simple elemental areas of a given complex area, and the distances of those areas. Okay, with respect to the reference axis. Okay. So here, finding out these x bar and y bar values for different simple areas, one should know how to identify the centroids of different simple areas with reference to with respect to different uh, reference axis. Okay. So now, so let us consider the right angle triangle, which is like this. Okay. So by just looking at the figure, okay, you should identify the centroid of approximately where exactly the centroid lies. Okay, so here is the location where the centroid will be there. Now, so we know that the centroid of a triangle, for a centroid of a triangle, for a triangle, centroid lies at a distance of 1/3 from the base of the triangle. So this is actually the base. So 1/3 of height. Okay. So h by 3. That is nothing but y bar. Okay. Next, the distance of centroid from y-axis will be called as y bar. Okay. Sorry, x bar. Distance of centroid from y-axis is called as x bar, and that will be equal to, because this will act like a base for this triangle with in this direction. So x bar will be equal to 1/3 of the base. Okay, that's nothing but b by 3, right? So that's how we will be finding out the centroid of a right angle triangle with respect to the reference axis given in this figure. Now let us consider another figure where you have the orientation of the triangle. It's little different, and the given reference axis passes through the leftmost corner point. I mean, the leftmost corner point of the figure and bottommost edge usually. Okay, and so is the case in this given figure. Now, as I told you, we should first identify the approximate location of the centroid. Let G be the centroid. Okay, we know that distance of centroid from y-axis is called as x bar. Okay, distance of centroid from x-axis is called as y bar. Right. Now, we know that from the base of the triangle, the centroid lies at a distance of 1/3 from base. Okay, in this direction, in the vertical along like in this direction, it is 1/3 of this height. Right. Next, in the horizontal direction, so this will act like the, so because in this direction, so this will be the base, this will be the height, right? So, and this will become the apex of the triangle. Okay. Now, from the apex of the triangle, the centroid will lie at a distance of 2/3 of the width. Okay, in that direction. So 2/3 of b. Understood? That's how we should find out. We'll have to find out the centroid in this case. Next, let us consider a symmetrical area or isosceles triangle which is symmetrical about the vertical axis along this, right? So this is the symmetrical axis, axis of symmetry, right? And if the axis of symmetry, if it is present in the given figure, so what we need to do, usually we need to take, we can take that as the axis, one of the axis. Like in this case, it can be taken as y-axis, but in the given figure, they have mentioned about the reference axis, so we should not consider the axis of the symmetry as the reference axis, okay? So we have to find out the centroid with respect to the given reference axis only. Do not consider or do not imagine any other reference axis. Now, always in case of symmetrical figures, the centroid will lie on the axis of symmetry. And so because as I've already told you, this you need to first identify or approximately identify the centroid location. Next, we know that from the base, in this, because it is in this direction, this is the base. So from base, the centroid will lie at a distance of 1/3 of the height, okay, 1/3 of height, and that becomes y bar, right, in the y direction, because it is distance from x-axis, hence it is y bar. Next, the distance of centroid from y-axis will be called as x bar, and we know this base width is b, and because this is the axis of symmetry, the centroid is lying on the axis of symmetry, so it will divide the figure into two parts. So x bar will be equal to b by 2. Okay, so that's how we should find out here. Next, let us consider another orientation of this isosceles triangle. And here, as I already told you, centroid will lie on this axis of symmetry as usual, because now axis of symmetry is horizontal. Definitely the centroid is lying on the axis of symmetry, and because for this direction, okay, let us know. Now identify x bar and y bar. The distance of centroid from y-axis is called as x bar. Distance of centroid from x-axis will be called as y bar. But since here the centroid is lying on the axis of symmetry itself, or axis, the reference axis itself, or the x-axis itself, y bar is equal to 0. Whereas you will get the value of x bar, and we know that in a triangle, the centroid lies at a distance of 1/3 from base of the triangle, whereas 2/3 from the apex of the triangle. Now in this case, so this is b by 3, okay, whereas this will be equal to 2/3 of this height, this dimension, 2/3 of b, right? Next, now let us consider the further other cases. So in the case of semicircle, we know that the centroid lies on the axis of symmetry. Okay, this is the axis of symmetry. Therefore, the distance of centroid in case of semicircle is 4r by 3 pi from the base. Okay, one of the diametric axis. Okay, this is diametric axis. From diametric axis, the distance of centroid G is given by 4r by 3 pi. And since the reference axis Y is along the axis of symmetry, therefore the centroid is lying on the reference axis, therefore x bar is equal to 0, and distance of centroid from x-axis is called as y bar, and which is equal to 4r by 3 pi in this semicircle. Now if you consider the quarter circle case which is shown in the figure, so as I said, first let us identify the centroid approximately. Let G be the centroid, and it is already been proved that the distance of centroid from the diametrical axis will be given by 4r by 3 pi even in the case of quarter circle. So this is 4r by 3 pi, and even the distance of centroid from the x-axis is also 4r by 3 pi, But the difference here is, we know that the distance of centroid from y-axis is x bar. So this is x bar, and distance of centroid from x-axis is called as y bar. So the notable difference which is there in this problem is the figure is lying on the negative side of the x-axis, and the value of x bar will be negative, right? So this is negative because left hand side, whereas y bar, I mean this y bar will be positive only. Y bar is equal to positive because it is on the positive side of the y-axis. So that is the only difference in this case. Next, let us consider other orientation of the semicircle. So anybody, those if they know about finding out these kind of, I mean, centroids of these kind of figures, they can confidently solve any complex problems in case of centroid. Okay. Now let us consider this figure. So as usual, the centroid lies on the axis of symmetry, and we know this is x-axis, and centroid is lying on the x-axis. Therefore, y bar is equal to 0. So there is no distance between x-axis and g. So y bar is equal to 0. Next, as usual, the centroid lies at a distance of 4r by 3 pi in case of semicircle. Okay, and since this is actually in the x direction, so it will be x bar. Okay, distance of centroid from y-axis will be called as x bar. Therefore, x bar is equal to 4r by 3 pi. One condition kept in mind, that's nothing but negative. This value should be negative because it's on the left side of the y-axis, or it is on the negative side of the x-axis. So it is minus 4r by 3 pi. Now in this case, if we consider, okay, this case, here definitely, so this is x bar, and here this is y bar, and since x bar is also negative, y bar, I mean the centroid is lying on the left hand side, on the negative side of x-axis as well as negative side of the y-axis. X bar and y bar are given by x bar is equal to minus 4r by 3 pi, and y bar is also equal to minus 4r by 3 pi. Okay, so that's how you will have to find out the centroid of the different figures. Okay, before going into this one problem, okay, general problem, so let me take up one more example. Okay, instead of considering the x-axis and y-axis here, so if I take the y-axis here, what actually happens? Let us see. So if we consider this as the y-axis, now let us see what will be the case. Now the centroid is nothing but or the x bar is nothing but distance of centroid from y-axis. Okay, now this becomes the x bar, whereas here earlier it was, this was the x bar, right? Now what is the x bar value? X bar is nothing but now the distance of centroid from this y-axis, which is a changed one. Okay, we usually know the distance of centroid in case of semicircle or quarter circle will be with respect to the diametric axis, but in this case we need with respect to this tip. Okay, the sharp edge. So that is given by this x bar can be given by, right, this is not the x bar now. Okay, so this is equal to 4r by 3 pi always. Okay, this will be 4r by 3 pi only, but x bar in this case is given by x bar is equal to r minus 4r by 3 pi. Okay, r minus 4r by 3 pi. Now let us consider one general problem, and if you can able to identify the x bar and y bar, okay, you can easily solve the problems. That's nothing but finding out the centroid of complex areas. Okay, now so let us in the case of this complex areas, complex figures, first you need to identify different areas. Okay, we need to divide the given complex area into simple elemental areas. So let A1 be the this area, and let this be A2, which is a rectangle one, and let this be a triangle, which is, let us consider it as a A3. Okay, so there are three areas: one semicircle, one rectangle, and one isosceles triangle. Okay, so and also you need to identify the centroids of these figures. Okay, uh, so the centroids of these figures, as I've already told you, you need to roughly identify. So approximately, now we know semicircle centroid will lie on this axis of symmetry, so let that be G1. And we know for a rectangle, the centroid lies exactly at the center. Let this be G2. And this is an isosceles triangle, which is a symmetrical about the y-axis, and definitely the centroid lies on the y-axis, whereas it will be there at a distance, some distance from the base. So let this be G3. Now the reference axis is somewhere here. Okay, so this is x-axis, and this one is y-axis, right? Now, for finding out the centroid, you need x1, x2, x3, y1, y2, y3 values, right? So that value can be determined by considering the concepts which we have covered in these figures. Okay. Now let us find the distances of these centroids from the reference axis. Firstly, let us consider x1. X1 is nothing but this distance of figure 1 from the y-axis. Okay, centroid of figure 1 from y-axis. That's nothing but this dimension. Okay, distance of G1 from y-axis is called as x1, and we know that that is exactly lying on the half in the center. So the radius has been given right here. So radius is given as this value, and this is nothing but r itself, right? Therefore the distance x1 will be equal to r only, because the distance of this from here, it will be r only. Okay, next next consider the distance x2. X2 is nothing but distance of centroid from the G2, distance of centroid G2 from y-axis, and that we call it as x2, and x2 is also equal to r, because the dimension of this will be equal to 2r. Okay, therefore half of it will be equal to r. And once again, the distance of G3 from y-axis is also r, and actually that's nothing but x3. Therefore x3 is equal to r. Next, let us consider the y values. Okay, distance of G1 from x-axis, this is actually y1, and because this is the diametrical axis, from diametrical axis the centroid of a semicircle will be 4r by 3 pi. And remember, since the figure is lying on the negative side of the y-axis, it will be negative. Therefore y1 is equal to minus 4r by 3 pi. Next, y2 is nothing but distance of centroid G2 from x-axis, and that is given by that's actually, this is a rectangle, so centroid will always be at the center, so d by 2, because it is the dimension in the vertical direction is d, therefore y2 is equal to d by 2, and it is positive because on the positive side of the y-axis. Next, y3 is nothing but the distance of G3 from x-axis, and it is from here to this point. Okay, and that's nothing but sum of distance from here to here, which is nothing but 1/3, because this is an isosceles triangle, and from base it will be from the base of the triangle it will be 1/3 of this height. That height is given as h, so therefore h by 3. Therefore the total distance y3 from here to here is given by d plus h by 3. This d from here to here plus h by 3. Therefore d plus h by 3, right? So this is how we need to locate the distances of centroid from of different simple areas in a complex figure, okay, using the basic formulas, okay, of the rectangle, triangle, semicircle, quarter circle, etc., etc. Okay, so if you know these things, you can easily solve any kind of problem very easily. Okay, so that's the end of this class. Thank you.